डियर स्टूडेंट्स, अस्सलाम वालेकुम। जैसा कि आप जानते हो, पहले दो लेक्चर्स में हमने मैग्नेटिक फ्लक्स और फैराडेज लॉज ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन डिस्कस किए हैं। जहाँ तक फैराडेज के सेकंड लॉ का ताल्लुक है, इंड्यूस्ड ईएमएफ इज इक्वल टू एन डी फाई divided by dt, where E is magnitude of induced EMF, n is the number of turns in the coil, and d phi divided by dt is the rate of change of flux. So when an induced EMF is produced in a coil, it sends the current that is known as induced current, right? And what is the direction of the current, or in which direction the current flows, that was given by the Lenz in the form of a law known as Lenz's law. So today's topic is Lenz's law, that is the direction in which the current flows or the polarity of the induced EMF, right? So we will discuss today Lenz's law. So first of all, I will give you the statement of the Lenz's law. The induced EMF in a coil is such that it opposes the cause that produces it. This is simple statement of the Lenz's law. The induced EMF in a coil is such that it opposes the cause that produces it. So let us consider a coil. So this is conducting coil. When the north pole of the bar magnet is taken towards north, and this is south pole. North pole of the magnet is taken towards the coil, or the north pole of the magnet is taken away from the coil. South pole of the magnet is taken towards the coil, or south pole of the magnet is taken away from the coil. यानी नॉर्थ को टुवर्ड्स लेंगे, नॉर्थ को अवे लेंगे, साउथ को टुवर्ड्स लेंगे, साउथ को अवे लेंगे. इन ऑल केसेस क्या होगा यहाँ पे? देयर इज चेंज इन फ्लक्स in all cases, either a decrease or increase. When magnet is taken towards, there is increase in flux. When magnet is taken away, then there is decrease in flux. So that is change in flux. When there is change in flux, as you know, there is induced EMF, right? When there is induced EMF, there is induced current. And what is the direction of the current? The direction of the current, in first case, when north pole is taken towards, there will be the current in the coil in anti-clockwise direction. Why in anti-clockwise direction? that is proved experimentally, right? We will prove it in our lecture. So when North Pole is taken towards, or North Pole is taken away, South Pole towards, or South Pole away, in all cases there is change in flux. Change in flux is the cause of the induced EMF. When there is induced EMF, there is induced current. So in first case, when North Pole is taken towards, then there is the current in anti-clockwise direction, which is represented as ACW, anti-clockwise. So you might be remembering the clock rule. Clock rule means when current in the coil is in anti-clockwise direction. So here we will write the direction of current like this. Here the direction of the current like this. So by joining this, it becomes an English letter, that is N, which indicates the north. That is the face approaching to you, that is, or front face, that is north, and the rear or the back side will become the south. So this face of the coil will become north. So when North Pole is moved towards the north, what happens there? Repulsion takes place. So repulsion takes place, that means it opposes the cause that produces it. जब हम नॉर्थ पोल को आगे ले जाते हैं तो यहाँ पे भी नॉर्थ पोलरिटी डेवलप हो जाती है, दोनों में रिपल्शन हो जाता है, लेकिन ये नॉर्थ तो इट इज बिकॉज ऑफ द मोशन ऑफ द मैग्नेट, सो इट opposes the cause. Similar is the case when north pole of the magnet is taken away. North pole of the magnet is taken away from the coil. Again there is decrease in flux. यहाँ पे तो increase हुआ था, that is there is change in flux. Change in flux. When there is change in flux, there is induced EMF. Induced EMF. When there is induced EMF, there will be the induced current. Induced current. So when there is induced current, what will be the direction? The direction will be, in this case, clockwise, because in first case there is increase in the flux, but here it is decrease in the flux. So here the current will be in clockwise direction, right? So according to the clock rule, when direction of the current is clockwise, then we can write it as like this. This is the direction in the upper portion, and this is the direction in the lower portion of the coil. So by joining this, you will get here S. So it means the face approaching to the observer will be the south, and the rear face will be the north. So when north is taken away, what polarity is developed in the coil? That is near on the nearer face, south polarity. What is the force between north and south? That is attraction. तो यहाँ पे रिपल्शन होगा फर्स्ट केस में, रिपल्शन. तो यहाँ पे जब देख लेंगे हम तो यहाँ पे अट्रैक्शन होगा, अट्रैक्शन. तो हम मैग्नेट को अवे ले जाना चाहते हैं, बट द कॉइल अट्रैक्ट्स इट. हम मैग्नेट को टुवर्ड्स लेके जाना चाहते हैं, बट इट रिपेल्स इट. सो दिस इज नोन एज द opposition to the cause. Induced EMF in a coil is such that it opposes the cause that produces it. So when north pole is taken towards or north pole is taken away, in that case, in first case there is north polarity on the nearer end or nearer face. In second case there is south polarity. In first case there is repulsion, and in second case there is attraction. So this is known as Lenz's law. Therefore, Faraday's second law, magnitude of induced EMF is equal to now minus n d phi divided by dt. So where negative sign indicates that induced EMF is opposite to the rate of change of flux. Rate of change of flux. So in general we can say when flux linked with the coil increases. Increase means when north pole is taken towards. Flux linked with the coil increases. The current is in anti-clockwise direction. One thing. Second one. When flux decreases, then current is in clockwise direction. Current is in clockwise direction. Now, how to verify the law? Experimentally. जैसा कि हमने कहा नॉर्थ पोल को हम लेंगे टुवर्ड्स या नॉर्थ पोल को लेंगे हम अवे, जहां पे चेंज इन फ्लक्स होगा, इंड्यूस्ड ईएमएफ होगा, इंड्यूस्ड करंट होगी और उसकी डायरेक्शन क्लॉकवाइज और एंटी क्लॉकवाइज. दिस वाज प्रूव्ड बाय लेंस एक्सपेरिमेंटली. सो हम यहां पे देंगे इसकी एक्सपेरिमेंटल वेरिफिकेशन. एक्सपेरिमेंटल verification of the Lenz's law. So in the experimental setup there is a coil connected to a sensitive galvanometer through a two-way key to a battery. So this is terminal 1, 2 and 3, and this is negative pole of the battery, and this is positive pole. So 1, 2, 3 means two-way key. So in the experimental setup there is a coil connected to a battery, oblique cell, and a galvanometer through a two-way key. Two-way key, 1, 2, 3. So step number 1. First of all, we will connect here the terminal 1 and 2. So connect terminal 1 and 2. That is, the battery is included. Battery is included in the circuit. Therefore, current flows through it. So what will be the direction of the current? That you know, if we connect 1 and 2, so this will be the direction of the current in the coil. So in coil, it will be in anti-clockwise direction. In the upper phase, anti-clockwise direction. Anti-clockwise direction. So let the galvanometer shows the deflection towards the right. So connect to terminal 1 and 2. That is, the battery is included. Battery is included in the circuit. It sends the current through it. Therefore, in the upper end, what is the direction of the current? Direction is in ACW, anti-clockwise. So according to the clock rule, you know, when in a phase, the direction of current is anti-clockwise, will that become north or south? North, exactly. So this end will become north and this will become south. So this will become north and this will become south. So upper end becomes north, right? And lower south. That is, the coil behaves as a magnet. जैसा कि आप जानते हो, आपने पढ़ा भी है, ये सोलिनॉइड है. It becomes a magnet. One end north polarity, one end attains north polarity and another end attains south polarity. Outside the solenoid, field is almost zero, but maximum and uniform field is inside. So this will become a magnet. Upper end attains north polarity and the lower end attains south polarity, right? Now in the step number 2, what we have to do, we have to disconnect 1 and 2 and connect 1 and 3. So connect 1 and 3 by disconnecting 2 and 3. Sorry, by disconnecting 1 and 2. By disconnecting 1 and 2. So battery is excluded. Battery is excluded. So there is no current due to the battery which is in the circuit because we have excluded it. हमने दो टर्मिनल्स को, इस बैटरी के टर्मिनल को डिस्कनेक्ट किया है. अब तो ये सर्किट से आउट है. अब हमने 1 और 2 को कनेक्ट किया, तो इसका फंक्शन यहाँ पे कुछ भी नहीं है. नाउ अब हमें करंट इसमें फ्लो करानी है. नाउ व्हाट वी विल डू, तो हम एक मैग्नेट को लेंगे, यहाँ पे बार मैग्नेट को. इस बार मैग्नेट का जो नॉर्थ पोल है, इसको लेंगे हम टुवर्ड्स द नॉर्थ पोल. सो पहला स्टेप हमारा था कनेक्ट द टर्मिनल 1 and 2. बैटरी इज इंक्लूडेड इन द सर्किट. current flows through it. In the upper end, the direction is in anti-clockwise direction. Anti-clockwise. Upper end becomes north and lower south. चलो एक बात और मैं ऐड कर लेता हूं. Let galvanometer shows deflection towards right. ठीक है. तो अब हमने इन दो टर्मिनल्स को डिस्कनेक्ट किया. अब हमने 1 और 3 को कनेक्ट किया. जो हमारी बैटरी है वो सर्किट से आउट हो गई. इन दो को कनेक्ट करने के बाद अब हम कैसे इसमें करंट फ्लो कराएंगे? देन वी हैव टू मूव द मैग्नेट टुवर्ड्स और अवे फ्रॉम इट, सो दैट देयर इज अ चेंज ऑफ फ्लक्स. चेंज ऑफ फ्लक्स होगा तो इंड्यूस्ड ईएमएफ होगा. इंड्यूस्ड ईएमएफ होगा तो इंड्यूस्ड करंट होगी. नाउ कनेक्ट दिस. सो मूव n pole towards the coil. So what happens there? Again galvanometer shows, यहाँ ऐसे लिखेंगे, towards the coil. What will be there? Increase in flux. Increase in flux होने से क्या होगा? Induced EMF is produced. Induced EMF is produced. जब induced EMF होगा तो induced current होगी. Induced current. जब induced current होगी तो definitely deflection होगी galvanometer में. So there will be the deflection. But यहाँ पे जो प्रूव हुआ कि ये deflection again it is towards right. It is towards right. अब हम डिफ्लेक्शन की बात करते हैं कि किस डायरेक्शन में डिफ्लेक्शन आ गई? राइट डायरेक्शन में. जैसे कि पहले आई थी जब हमने बैटरी को कनेक्ट किया था सर्किट में, तब भी यहाँ पे डिफ्लेक्शन आ गई थी राइट. और अपर पोल क्या था? अपर फेस क्या था? अपर एंड क्या था? नॉर्थ. राइट. अब जब हमने नॉर्थ पोल को मूव किया टुवर्ड्स, इंक्रीज इन फ्लक्स हुआ, इंड्यूस्ड ईएमएफ हुआ. इंड्यूस्ड ईएमएफ के बाद इंड्यूस्ड करंट से डिफ्लेक्शन प्रोड्यूस हो गई और वो डिफ्लेक्शन भी टुवर्ड्स राइट आ गई. ठीक है. सो अपर फेस क्या होगा अब? नॉर्थ. सो अपर फेस इज नॉर्थ. ठीक है. सो व्हाट विल हैपन देयर? रिपल्शन टेक्स प्लेस. जब रिपल्शन हुई, दैट मीन्स अपोजिशन टू द कॉज. अपोजिशन टू द कॉज. देखो बेटा, इसमें करंट फ्लो हुई ड्यू टू द मूवमेंट ऑफ द मैग्नेट, लेकिन मैग्नेट को ये अपोजिट कर लेता है, अपोजिशन कर लेता है, इसको आने ही नहीं देता है, क्योंकि यहाँ पे नॉर्थ पोलरिटी डेवलप हो जाती है. जब नॉर्थ पोलरिटी डेवलप हो जाएगी तो रिपल्शन होगा. Repulsion means opposition to the cause. Similarly, if n is taken away, what happens? Decrease in flux. ठीक है. जब decrease in flux होगा, there is induced EMF. जब induced EMF होगा तब यहाँ पे current होगी. But in this case, the current is in clockwise direction. That is, deflection reverses. Reverses its direction. पहले राइट डायरेक्शन में थी, अब लेफ्ट डायरेक्शन में. तो अब ये वाला एंड क्या हो सकता है? अपर एंड बन सकता है. अपर एंड होगा साउथ. साउथ और नॉर्थ दोनों क्या करेंगे आपस में? अट्रैक्शन. अब तो हम इसको अवे लेके जाना चाहते थे, लेकिन ये अट्रैक्ट हो जाता है. सो इट गेट्स अट्रैक्टेड. राइट. सो दिस इज एक्सपेरिमेंटल वेरिफिकेशन ऑफ Lenz's law. How it opposes the cause that produces it. Right, beta? So this law, whether it is in accordance with the law of conservation of energy or not, you have to prove it. Whether the law is in accordance with the law of conservation of energy. So Lenz's law. Lenz's law in accordance with law of conservation of energy. देखिए बेटा, you know what is law of conservation of energy? अब लिखने की जरूरत नहीं है, ये जानते हो आप. Energy can neither be created nor destroyed, but can be transformed from one form to another form. So there is transformation of the energy from one form to another, and total energy remains constant. Total energy remains constant, right? तो इस Lenz's law में क्या होता है? So magnet, there is a magnet which is taken towards the coil, or the magnet which is taken away from the coil. Towards the coil or away from the coil. दो पॉइंट्स में, दो स्टेप्स में मैं आपको बता दूंगा ये. अगर आप नॉर्थ पोल को लेंगे, it is taken towards, right? Then जो नियरर फेस होगा, नियरर फेस कौन सी पोलरिटी अटेन कर लेता है? सिमिलर पोलरिटी, दैट इज नॉर्थ पोलरिटी. नॉर्थ पोलरिटी, ठीक है. जब नॉर्थ पोलरिटी अटेन कर लेता है तो यहां पे क्या होगा? रिपल्शन. तो जब रिपल्शन होगा, हम मैग्नेट को आगे नहीं ले सकते हैं, right? So what we have to do in order to overcome the force of repulsion, to overcome the force of repulsion, work is to be done, right beta? So this is mechanical energy, work done, or mechanical energy which gets converted into electrical energy. Next case, when north pole is taken away, what happens? Nearer end or nearer face becomes south or north? No, south. It becomes south. तब यहां पे क्या होगा? अट्रैक्शन होगी. So in order to overcome the attractive force, we require energy or work done. That is, again, mechanical energy is required to move the magnet away or towards. Mechanical energy which gets converted into electrical energy. So in first case, work is to be done, mechanical energy is to be used to overcome the force of repulsion. In second case, when there is decrease in flux, what we have to do? Work is to be done against the force of attraction. So in both cases, mechanical energy gets converted into the electrical energy. चलो एक बात और भी कह लेते हैं. When magnet is at rest, right? There is no change in flux. So there is no work done, hence no induced EMF, and hence no current. Hence Lenz's law is in accordance with the law of conservation of energy. Okay, so in the next lecture हम डिस्कस करेंगे म्यूचुअल इंडक्शन और उसके बाद सेल्फ इंडक्शन होगा। कोशिश कर रहा हूं मैं कि आप लोगों को घर बैठे कुछ फ़ायदा हो जाए। चलो, थैंक यू।